Hello everyone. Today we are going to solve a very interesting question. The question is from the chapter of permutation and combination. And this question is a very high level question. You can expect such kind of questions in JEE mains and advanced. So the question goes like this. A regular polygon has 20 sides. How many triangles can be drawn by using the vertices but by not using the sides? पहले तो ये क्वेश्चन में रेगुलर वर्ड हो ना हो कोई फ़र्क नहीं पड़ेगा, नॉन रेगुलर से भी काम चल जाएगा. ठीक है, सो ये वर्ड कोई फ़र्क नहीं करता. Then the next thing, the polygon has 20 sides. Okay, how many triangles can be drawn? So let me say I have a polygon. Obviously I won't be able to draw 20 sides, but let us assume that I have drawn 20 sides. 1 2 3 4 5 so and so and so 20. ठीक है, so 20 sides यानी 20 vertices are there. Let us assume that there are 20 vertices. Now you need triangles. Okay, so for a particular triangle to be drawn you need 3 vertices, right? You can select the 3 vertices like this. Let us say you selected 1, then you selected 3, and then you selected 5, and then you join these 3. You will get a triangle. Now this triangle can be counted because no side of the triangle is the side of the polygon. But suppose if you select 1, 2 and 5, then what will happen? The triangle be drawn like this. So you can see one side of the triangle is coinciding with the side of the polygon. So no side of the triangle should be coinciding with the side of the polygon. That's what they have said over here. How many triangles can be drawn? By using the vertices but by not using the sides. You do not have to select the side of the polygon. For example, I'll give you one more. Suppose you selected 1 2 and 3. So the triangle be drawn like this. These two sides of the triangle 1 2 and 2 3 are the sides of the polygon also. So this triangle can also not be considered. But if you select 1 4 and 20, that will also not do, right? That will also not do. Suppose there is some point 17, 1 17 and 4, and then you draw the triangle. This triangle will be okay. So in short, what they are saying is do not select consecutive vertices. If you select vertex 1, you cannot select 2 and 20 because then that will form the side. Then you can select 3, but if you select 3, you cannot select 2 and 4. Then if you select 4, you cannot select 5 and 3 because that will form the side of the polygon. So you might have understood that this question resembles something like this, that out of this 20 vertices, you have to select only 3 vertices such that those 3 vertices are not consecutive. If you by mistake select consecutive vertices, you will be selecting the side of the polygon, which won't be right. So that is the idea of this question. Now I am going to show a very fast method to do such kind of questions. You will take some time to understand, but once you understand, this type of questions can be done in a very fast manner. Okay, so the technique is something like this. Suppose if you have the points 1 2 3 4 5 6 7 8 and so on 20, and there is a polygon. Obviously I cannot draw all the sides, it will be very clumsy, so I have drawn some. Okay, now what I am suggesting you is you break the polygon somewhere here at the point 20. Suppose you have broken it, and after breaking it you arrange the vertices in a single line, something like this. So after breaking you get 1 2 3 4 5 6 and so on, and then 20. Okay, now there are 20 vertices, but they are not in a closed circular type figure, they are in a linear type figure. Okay, now our question was to select 3 vertices which are not consecutive. but initially it was in a circle type figure, yeah, circular permutation, circular figure, but now they are in a single line. Okay, now what we'll be doing is we need to select 3 points which are non-consecutive. I am simplifying the question in a linear manner, which are non-consecutive out of 20 points. Right? Now you know the trick for this. What do you do in such questions? We use a reverse technique from the linear selection. How? You have 20 points, out of which you have to select 3 non-consecutive points, right? So what we'll do, we will consider 3 points to be out from this 20 points. So how many points remain? There are only 17 points which remain. So 1, 2, 3, 4, 5 and so on, 17. So 17 points are arranged in a line. Now you will say, sir, arranging 17 identical points in a line, the number of ways is 1 only, because you are arranging 17 identical points in a line because they are identical. So 17 points are identical, arranging them is only one way, so there is no problem with that. How many gaps they are going to give? We are going to use gap method. How many gaps? 1, 2, 3, 4, 5, 6, so and so on, and there is a gap after 17 also. So you can see there are in total 18 gaps. Okay, if you have problem in identifying the gaps, I will simplify it. Suppose if you have 1, 2, 3 points, 4 points, let us say, how many gaps they are going to give? 1, 2, 3, 4, 5 gaps, right? So always in linear combination there will be one gap extra, right? So there are total 17 points. 17 points are going to give how many gaps? 18 gaps. Now you can select these gaps. Okay, how many gaps do you want? You want 3 gaps only, because you want 3 non-consecutive points. So it's a reverse technique for difficult question. There's one more technique for such question, but that is a bit lengthy. This is a reverse technique in which what we do, we arrange the 17 objects first and then we check out the gaps. There were total 18 gaps, and out of these 18 gaps we will select 3 gaps. Okay, so number of ways, I'll write it down over here. Number of ways is equal to 18C3. Now this is the reverse technique. What did I do? I selected 3 gaps from 18, but these 3 gaps, let me say I selected this gap, I selected this gap, and I selected this gap. Okay, over here there's 0.6, let us say. You can see all these 3 gaps are non-consecutive. The remaining 3 objects can be filled in these 3 places, right? So that way we get 3 non-consecutive points. This is the reverse technique in which we got the answer as 18C3. So you will say, sir, is the answer 18C3? Definitely not. 18C3 is not the correct answer, because we had a circular figure, right? This is a closed figure, but we considered a linear figure. So that way it will be a problematic thing because we changed the figure. But the problem is over here where we cut the figure. We cut the figure at the point number 20. So what will happen if I selected this gap before 1 and this gap after 17? What will happen? Because we have cut the figure, but in short that will be joined to form a closed loop. So this gap and this gap is the same, right? Because 1 and 20 are consecutive, and over here 1 and 20 are not consecutive. But over here you see that this gap and this gap is not consecutive. But once you select the gaps, let me say you selected this gap and this gap, after that you will rearrange that in a closed loop, right? But once you arrange that in a closed loop, this gap and this gap will coincide, and you have selected a single gap twice, so that will be wrong. right? So what we need to do is we need to subtract the wrong combinations. And what are the wrong combinations? When you select this gap and this gap, that is the wrong combination. So this gap and this gap can be selected only in one way, that is the leftmost gap, and the rightmost gap can be selected only in one way. So I will have to write down -1 into 1. But in total we were selecting 3 gaps. Now the third gap is to be selected. The third gap can be selected from the remaining gaps. So there were total 18 gaps and these 2 gaps are gone. Remaining gaps are how much? 16 gaps. Out of those 16 gaps you have to select one. So I used the principle of exclusion, you can say. The total number of ways of selecting gaps was 18C3, but in those selection of gaps I made the wrong selections, in which I selected the leftmost and the rightmost gap. After closing the figure, the leftmost and the rightmost gap will coincide, which will be actually wrong because you are selecting the same gap twice. Okay, so that is a wrong combination. So this gap and this gap can be selected in one way, and remaining 16 gaps I will need to select one more gap because in total we were selecting 3 gaps. So this is total and this is wrong. So total minus wrong is right. So that is the number of ways for the question. The question was how many triangles can be drawn by using the vertices but not by using the sides. So what will be the answer? Let us see. 18C3 is 18 into 17 into 16 upon 3 into 2 into 1. 16C1 is 16. So 3 into 2 6, 6 3s are 18. So this would be 16 into 51 minus 16. So that would be, I can take 16 common, 51 minus 1. So that would be 16 into 50. 16 into 50 is 16 5s are 80. 800. So in short, 800 triangles can be drawn by using the vertices but by not using the sides of the polygon. So that is how this can be done. Obviously I took so much amount of time to make you understand the technique for this particular question, but I hope once you understand it will be very easy for you. So let me do one change in the question and we will solve one more question so that you understand this in a better way. So let me change this 20 to 10. So a polygon has 10 sides. How many triangles can be drawn by using the vertices but not by using the sides? Simple. So you have a polygon in which there are 10 vertices, right? Okay, and you have to select 3 vertices which are non-consecutive. So what will you do? You will cut the figure at the point 10, arrange them in a line. But you need to select 3 vertices which are non-consecutive. So out of this 10 you will take 3, take them out and arrange the remaining 7. As all the points are identical, arranging them takes only one way. The number of gaps that it is going to give you: 1 2 3 4 5 6 7 8. Out of these 8 gaps you need to select only 3 gaps, so that will be 10C3 minus. But when you select the leftmost and the rightmost gap, they are actually going to coincide because it has to in turn form a closed figure. So selection of this leftmost and rightmost gap is actually wrong. So 1 into 1, and from the remaining, my bad, over here there were 8 gaps, right? Because there are 7 points now. So there are total 1 2 3 4 5 6 7 8 gaps. So 8C3, sorry. Out of those 8 gaps you selected 3 gaps which are non-consecutive, but this linear figure has to be converted into a closed figure. So leftmost gap and rightmost gap actually coincide. So selection of leftmost and rightmost gap happens in one way. From the remaining 1 2 3 4 5 gaps, 6 gaps, 1 2 3 4 5 6 gaps, you have to select only one, and this is your answer. 8C3 minus 6C1. Very easy to calculate. 8 into 7 into 6 upon 3 into 2 into 1 is 6 minus 6. So 6 got cancelled. 8 into 7 is 56. 56 minus 6 is 50. So 50 triangles can be drawn. So it was pretty easy, right? What did we do? We had 7 points and then 8 gaps. Out of those 8 gaps we selected 3 gaps which were non-consecutive, but that will be again converted into a closed figure, so left and rightmost gap will coincide, so selection of that is one way. And out of the remaining 6 gaps we selected 1, so total was 8C3 and wrong was 1 into 1 into 6 into 1. Total minus wrong, we get the right answer, which is 8C3, which is nothing but 56 minus 6, 50 ways. Okay, so let me give you a homework question in which we have a regular polygon which has sides 15. How many triangles can be drawn by using the vertices but not using the sides? So there are other ways of doing this question also, but I find this technique to be very fast. It takes a little time to understand and to teach at first, but once you understand, it's just a one line answer. I hope you like this video. If you like this video तो मजे करो and questions solve करते रहो. आज के लिए बस इतना ही. This is your friend Amol More saying bye bye to you.